Okay, good evening. My name is Yusuf bin Aan, from Group 1. Our topic for this group is metric elementary row operation, which is a ERO. Okay, so this thing is prepared by myself, Yusuf, Kumar, Ashwin, Aiman, Kartik, Faris, and Eddie. Okay, so we're moving on into introduction. So what is ERO? Okay, so what's the function of ERO? Okay, so ERO, elementary row operation, is a method of operating on a metric that is used to find the inverse of matrix and also used to solve a system of linear equations. Okay, so we use ERO to find the inverse from matrix. Okay, so ERO is used to derive row echelon matrix from a non-row echelon matrix. Okay, so later on you will understand what is row echelon matrix, which is REM, and non-row echelon matrix. Okay, and used to derive a RREM, which is row reduced echelon matrix, from a row echelon matrix. Okay, later you find out that these both are somewhat more related. So the process of ERO, there are three main processes ERO, which are: number one is interchanging the I row with the J row of the matrix. This process is shown as RI interchange RJ. Okay, later I explain to you, later I give you the example. So the second one is multiplying, and the third one is adding. Okay, I don't want to explain too much because it's easier to show an example. So this is the example. Given that A, so that is the matrix of A, 1, 2, 2, 3. Okay, so the A, which is the first one, the interchange B1 interchange with B2. Okay, with the B1 is the row, so row 1 interchange with row 2. So as you can see, so from the first one and the second one, it change the row. Okay, that's what it means by interchanging. Okay, so the second one is multiplying. So it's the simple, I think. So negative 5 B2, which is row 2. So everything from row 2 multiplied by negative 5. And then lastly we have adding. Okay, so B1. Okay, so if you look at the equation, so B1 plus negative 3 times B2. Okay, so this thing is for the first row. It's for the B1 now. It's for the B1 row. So as you can see, so all the thing from the second row times with the negative 3 and then add with the B1, which is the row 1, and that answer is for the row 1. Okay, so the note, okay, when a metric B is derived from metric A, okay, so that A, B derived from that A, that B, sorry, so the A is called the equivalent matrix to the metric B, and it can be noted as that symbol over there, A equivalent to B. Okay, so here are the problem statement: how to perform REM and RREM using elementary row operation. Okay, so this one my next member will explain it to you guys. Okay, that's all for me.
Hello, good evening everyone. This is Ashwin presenting for the mathematics assignment. So I'm gonna present REM and RREM today. So what is REM? REM, or row echelon matrix, is a matrix derived when elementary row operations are done on a matrix. So a REM must have particular features to it, or particular properties to it, in order for it to be an RREM. The first few properties is that it must have at least one non-zero row, or it shouldn't be a zero matrix. So as you can see, this matrix right here on the screen, it has two non-zero rows. So yeah, a REM must have at least one non-zero row. The second property is that the entity to the left of a row must be 1. That meaning to say that if a row starts, a row when going from left to right, it must the first entity that you must see must be 1. Okay, next property says that the leading one in the row below a row must be to the right of the leading one in the above row. As you can see, in matrix A, the leading one in the top row and the middle row, the leading one occurs to the left in the top row when compared to the middle row. That is not an REM, but in in the matrix B is an REM because the leading one in each descending row is to the left of each other, or the row, the leading one in the row below every row is to the right, to the leading one in the row above. Now the fourth property is that rows that have only zeros must be at the bottom of the matrix. As you can see in this matrix, the row containing all zeros is at the bottom of the matrix. So this is an example of an REM. Last but not least, the element below a leading row must all be zero. In this matrix, we can say that this matrix is an REM because below each leading one there is a zero below it, so it's an REM. Now coming from row reduced REM, we now see row reduced echelon matrix, that's RREM. This is just similar to REM except that it has one extra property that says that if a column contains a leading one, it must have zeros everywhere else along the column. So as you can see in this matrix, in every column that has a leading one, it has zeros in the other spaces. So this is an RREM. It must have zeros everywhere else on the column where a leading one is situated. Now in conclusion, a row reduced echelon matrix can be a row echelon matrix. A matrix that is not a row echelon matrix cannot be a row reduced echelon matrix. A matrix that is a row echelon matrix cannot always be a row reduced echelon matrix. So let us look at some examples now. Determine if the following are REM, RREM or none. In the first row, in the first matrix, we can see that they are the second row. It doesn't begin with 1, so it's neither of them. The second matrix, it's an RREM because the row with all the zeros, they are at the bottom, and each row begins with 1. That is the leading one, and it is to the left of right of each other in the when it's descending. REM, all the rows, they all begin with 1 and they are to the left of each other, so it's an RREM. While the last matrix is RREM because the rows that contain leading ones, they have zeros everywhere else. So thank you, and I'll let my next member to continue. All right.
Hello everyone, my name is Muhammad Aiman, and today I will continue presenting this presentation on rank of matrix. So here we go. Alright, the rank of matrix is defined as the number of rows in a matrix that is non-zero in a row echelon matrix or row reduced echelon matrix. We can write rank of matrix as PA. So let's look into example 1. Given matrix A is 1, 6, 7, 0, 1, 3 and 0, 0, 0. From this matrix, we can see that there is only 2 rows which contain non-zero row, which is row 1 and row 2. So we can write as PA is equal to 2. We look into matrix B. Given matrix B is 1, 8, 5, 0, 1, 0 and 0, 0, 1. From this matrix, we see that all 3 rows contain 3 non-zero. So we can write the rank of matrix is PA is equal to 3. So we look into example 1. So example 1, given matrix A is 2, 5, 3, 1, 2, 1, negative 3, 1 and 2. Perform the following elementary row operation consecutively. So here we go. Alright, for the first operation, interchange row 1 into row 2. So we can interchange row 1 into row 2. So 2, 5, 3, 1, 2, 1, we can obtain the new matrix as 1, 2, 1, 2, 5, 3, negative 3, 1 and 2. The second operation is R2 plus with negative 2 multiplied by R1. So we can obtain the new matrix as 1, 2, 1, 0, 1, 1, negative 3, 1 and 2. The third operation is R3 plus 3 multiply by row 1. So we can obtain the new matrix as 1, 2, 1, 0, 1, 1, 0, 7 and 5. The third operation is row 3 plus negative 7 multiplied by row number 2. So we can obtain 1, 2, 1, 0, 1, 1 and 0, 0, negative 2. And the last operation is negative 0.5 multiplied by row 3, and we obtain 1, 2, 1, 0, 1, 1, 0, 0, 1. For example 2, I will let for my friend to explain about it. So that's all from me. Thank you.
Assalamu alaikum, a very good morning. My name is Faris Muhammad Abdul Majid, and today we're going to talk about example number 2 and example number 3. So we have example number 2, the matrix A, 1, 2, 1, negative 1, 0, 2, and 2, 1, 3, 3 by 3 matrix. We need to, number 1, find the echelon matrix, and 2, rank of matrix. So let's jump to it. First of all, the first row is really, we have the leading one in the first row, so we don't really need to touch that. We will just go to the second and third row. So we will see in the third row we have 2, 1, negative 3, and we want just to get rid of the 2 and replace it with 0. So we will add row 1 into row 3, so we can make it 3, and then multiply negative 3 by row 2 and add it to row 3. So what we will find now is 1, 2, 1, 0, 2, 3, and 0, negative 3, negative 5. Then we can start working on row number 2. So we can add row number 3 to row number 2. So we will make it negative 1. So R2 plus R3 we will have in the second row 0, negative 1, and negative 2. Then we will turn this negative 1 into positive 1, so we can have the leading one. So we will make negative 1 R2 and negative 1 R3. Now we will have the matrix 1, 2, 1, 0, 1, 2, and 0, 3, 5. Now we can start working on the third row. We want to delete the 0, make it 0. We want to delete the 3, make it 0, and also to change the 5 to 1. So we will make R3 plus negative 3 R2. Now that way we will have 1, 2, 1, 0, 1, 2, 0, 0, negative 1. And then just multiply negative 1 by row 3, we will have 1, 2, 1, 0, 1, 2, 0, 0, 1, which is the echelon matrix. For the next question, he asked us what's the rank of matrix, which is really simple. Since the REM or the matrix had 3 non-zero rows, so the matrix rank is 3, as simple as that. Now we will go to example 3, which contains 4 by 4 matrix, and he wants, from this question, he wants the echelon matrix, reduced echelon matrix, the RREM and REM, and also the rank of matrix. So let's jump into it. Okay, so first step is, which I recommend, when we find any row that starts with 1, immediately put it in the first row, so it can make your work easier. So we will change row 3 with row 1 as shown, because row 3 starts with 1. And after that, we also have the third row, the second element is 1, or the leading element is 1. So we will change row 2 with row 3, and now we will have the matrix as shown: 1, 3, negative 1, 2, 0, 1, 2, 3, 2, 3, 4, 5, 3, 2, 4, 1. Now we finished with the first matrix, we don't need to touch it. We'll just start to work with the second, third, and fourth matrix. So we have R3, negative 2, R1, and R4, negative 3, R1. Why? Because we want to make the first column zeros. So we will have 1 and zeros, 3, 1, negative 3, 2, and etc. After that, we will take the row 3 take the row 2, multiply it by 3, and add it to row 3. And for the row 4, we'll plus 7 R2. So we will have later this matrix: 1, 3, negative 1, 2, 0, 1, 2, 3, 0, 0, 12, 10, 0, 0, 21, 6. Now we're almost done with the row 3. We'll just need to make the 12 1. So we'll multiply by 1 over 12, and we finished row 3. So for the last row, which is row 4, we will subtract by 21 row 3, so we can make the third element in row 4 0, and after that we will have negative 3 over 2, just multiply it by negative 2 over 3, so we can reach the leading one in the fourth row. And this is the final matrix: 1 3 negative 1 2 0 1 2 3 0 0 1 5 over 6 0 0 0 1. This is if you want to make it REM. Now if you want to make it RREM, reduced Michelin matrix, what do you need to do? So first we will start working with R1, and we will multiply it by 3 R2, because as we shown, R2 starts with 1. So R1 will be minus 3 R2 and R1 plus 7 R3. Why? So we can have this matrix shown 1 0 0 negative 7 over 6. How to get rid of negative 7 over 6? We will use it by multiply the fourth row by 7 over 6 and add it for row 1 as shown. And R2 we will negative 2 R3, so we can get rid of the 2. So we will have this matrix 1 0 0 0 0 1 0 4 out of 3 0 0 1 5 over 6 and 0 0 0 1. Now we only have row number 3 and row number 4. We will just multiply it by the same value but row 1. So for example, we have 4 over 3 in the R2, so in the row 2 it will be minus 4 over 3 R3. Same goes for the row 3. R3 will be minus 5 over 6 R4, and we will have 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. And this is the reduced Michelin matrix. Last but not least, the rank of matrix. Since we have 4 non-zero rows, the rank will be 4. It's as simple as that. That's for me. Thank you so much. And now we'll go to my friend.
Hello, my name is Eddie. I'll be summarize the whole video. So, what is elementary row operation? Elementary row operation ERO is very important and powerful method that is used to work with matrices. ERO is used to find the inverse of matrix and can also be used to solve linear equation. This is done by using ERO to find the row echelon matrix, or known as REM, from a non-REM matrix, which can be used to find the row reduced echelon matrix RREM. But for this to be successful, the 3 elementary rows have to be followed correctly to allow precise calculation. That is all for all of us. Thank you very much and have a good day.